Oh yeah, it's going. Okay, so we're waiting for Reagan. Regham. Because today, we're gonna teach you physics! Yeah, I was starting to see if it worked, and then it did. So, we have a physics AP test tomorrow. Yeah.
It was a small marker.
And so, we wanted to go over all the physics stuff, but we got really lazy. And so the only way to motivate ourselves to do it was to create a YouTube video. So, this is for all those AP testers out there wanting to learn about physics taught by the worst student in the physics class.
We should show our physics classes and be like, I guess you guys wanted to learn.
They would be like, no. Okay, so our first unit was over fluids. And we first just started talking about density, which density is mass over volume, which is an intrinsic property, and it doesn't depend on how much there is.
Density. You ready for this one?
Oh, dude.
Density also equals mass divided by volume.
I literally just said that. And a good way to remember that is that if you draw a heart, can you see it? We're gonna have to use the purple. God, why did you choose purple? I guess you didn't get to choose. If you draw a heart,
Oh yeah, you can see that.
then it's like an M over V.
Or it's like DMV, like the place you go. Cars.
Because I'm good at creating things. And then so, fun fact, just of the day, water's an incompressible fluid, which I think I learned today.
Yeah.
Also, velocity is usually, no, you do
Let's
the thing.
talk about free body diagrams.
Free body
and,
diagrams.
Buoyant force.
Buoyant force.
So if you're in a container of water, right, here's our container.
Here's the water.
Yeah, water. And this is our little box. It's full of peaches. And
I like peaches.
so the force, there's a force exerting down, and that's of course our pressure. Or gravity. Wait, I don't know the answer.
What? Oh, that's mg.
Yeah, that's what I thought. Okay,
Yeah,
but then I
that's
remembered.
not pressure.
I know. And then there's a buoyant force that's pulling up. And also there's an alien taking Jesus, I think, is what he's drawing.
Alien and Jesus are very important when we're talking about physics.
Yeah. So, yes. So this
It'll
is the
just stay
thing.
there.
And do you want to go over how to calculate the buoyant force?
Well, buoyant force would equal mg if it's floating. So.
Oh, yeah. That's true.
So
Because net force
equals m.
equals
Hey! Shout out to Mr. Holloway. And also, if we're talking about this, if we're talking about this pressure, if we want to know, like, no, okay, we're gonna draw a new shape in this situation. And it's gonna be a little rock, just down there. There's a rock, and we want to know what kind of pressure is being exerted by the water on that rock. So pressure equal. Do I have to write backwards?
Wait, it might be because, like, it might go out.
Like
Normal.
Normal.
But this also might be what's coordinating.
Wait, you're just gonna have to read backwards. I'm sorry. Pressure equals force. I don't know how to draw that. Force divided by area.
Yes, that is a true
If
statement.
they're reading this like this one more thing, it's not gonna help. And so to measure the pressure exerted on the rock, we have to take the force, which is mg. That's what my note says. Divided by A, which is the area. Fun fact. It also equals. It also equals rho GH, which I feel like is something that is more common. So in that case, rho is just a constant. Check me on that. No, I think I'm wrong.
Oh wait, no, rho is density.
What the hell?
Yes.
Are you sure?
Yes.
Okay. Rho is just the density of the rock. Yeah, we're gonna fail this test.
It's okay. I've accepted the fail, and she needs a 4, and she's not getting a 4, so it's fine.
I got 3 last time. Not gonna get a 4.
You should take the test for me, and then maybe you can get a 3, and then I can just get a 1 for you, because it doesn't
That
matter.
would be the height that we're measuring. You can't even see it. Actually, you kind of can.
There's like dots.
That would be the height there that you have to measure, and the gravity is just 10, and rho apparently is density. You would need that. Also, very important, I feel like. We need a better eraser because my shirt's not gonna work. We have like this little doodad up in here. That was a terrible drawing. Pretend this is like.
I can say that these have the same pressure.
I think so.
That's true.
The height has to be measured to the top of the open air. So if the water goes from here, and this is air, it's not open air. It's closed still by the cave. So you have to measure from here. Yeah, good job, Regan. even if we're measuring the pressure from here, we have to measure it this height.
Ooh, also, fun fact, pressure depends on height and density. Buoyant force depends on volume and surface area. I don't really know how it is. It's on the equation sheet.
It's not an equation sheet, like,
yeah.
We'll be fine.
Also, volume flow rate. Let's go over that.
Okay.
AV, av.
You do that one.
Okay, av. So, av. That's really the most important thing. It's area.
Yeah.
Area times velocity equals area of the second one times velocity.
Little v's
Of the second
indicate
one.
velocity. Yeah.
And
That's very true.
you know, that just take it as it is.
That's just what it is.
And then
So if we get a greater area on the second one, that means velocity
Yeah.
has to go down.
And then there's also this fancy schmancy little thing that you get asked about a lot. And
Diagram.
here, the velocity is going to be faster.
But pressure
is
going down because of Bernoulli's principle that more velocity equals less internal pressure.
Yeah. So yeah.
Yeah. Yeah.
So that's a thing. I think that's.
Also, we can figure out the specific gravity of something if we take the density of the object over the density of water. That's just a little tidbit of knowledge that I have. Oh, and PATM is 100,000 pascals.
It's on the blue sheet.
Dude, good, because
Yeah.
I wasn't gonna remember that.
Yeah. Just kind of know that pressure's a thing.
Oh, here's a fun
I don't really
picture.
have anything else to share.
Here's a fun picture that I had drawn in my notes. Okay, so there's this like little doodad. Wait, so there's a huge tank of water, and there's a dude in the water, fully in the water. Okay, and he's holding one doodad over here. He's holding another doodad over here. And so the question was asking, is the buoyant force the same or is it different on the two objects? And the answer would be that they're the same because they displace the same amount of water and the same force is needed to hold them.
Depends on volume, I think.
Yeah.
Density.
Density and
Buoyant
force.
force.
And so since they're the same
Yeah.
boxes, it doesn't depend on the height.
Yeah. Yep. Unless it's above water, then that's like the whole different thing. Crazy.
Crazy. Okay.
Weird stuff. So if you want to move on to the thermos.
Thermo! I'll get this side. This is going to be like an hour-long video that no one's going to watch.
Do you want to do like different sections of?
Sure. We'll move
Like-
on to thermo later. Come back to us!
Subscribe!
Do we usually say something at the end of these?
We tried to do our handshake, but that did we don't. Are we still recording?
Yeah.
I feel like we need 2 hands.
We do. There was definitely something in the middle there. Bye.